Welcome to the tutorial on flip-flops and types of triggering.
Flip-flop is an electronic circuit with two stable states that can be used to store the binary data. The binary data is in the form of zeros and ones. So the stored data can be changed by applying the varying inputs. Moreover, you have flip-flops and latches, which are the fundamental building blocks of digital electronic systems, which are used in computers, communication, and many other types of systems. The types of the flip-flops are SR, D flip-flop, JK flip-flop, and T. The major difference between these flip-flops, that is SR, D, JK, and T flip-flop, are the number of inputs that they have and how they change the state. If you are to compare the difference between a latch and a flip-flop, latch does not have a clock signal, whereas a flip-flop has a clock signal. But both latches and flip-flops are circuit elements whose output will depend not only on the current inputs but also on the previous inputs and outputs. One of the main reasons being flip-flops and latches are sequential circuits. Now, before we understand the concept of the flip-flop, we should know the different ways in which the triggering occurs. So we have level triggering and we have edge triggering. Trigger basically corresponds to the state of a latch or a flip-flop in which it is switched by a change of the control input. And the types of the trigger can be level trigger or the edge trigger. The level triggering occurs in latches and flip-flops, whereas edge triggering is mainly confined to the flip-flops. So if you look at the figure, you have the figure here wherein you have the first figure which shows the response to a positive level. So here you can see that this figure corresponds to level triggering, and I have highlighted the positive side just to indicate that the level triggering occurs for the positive clock pulse. Okay, clock pulse or the positive pulse of the signal or the control signal, the control input. Whereas in the case of edge triggering, we have two types, that is positive edge triggering and the negative edge triggering. Positive edge triggering, as you can see, it is corresponding to the one when your signal is rising from 0 to 1. Whereas negative edge triggering occurs when your signal is switching from 1 to 0. So these are the various types of triggering, that is level and edge triggering. Now, why do we move to flip-flops when we already have latches? If we are using level triggered flip-flops, then the feedback path will cause instability problem because the time interval of logic 1 is too long, because you know that this is a combinational circuit with memory elements. So with level triggering, what happens is that there will be a longer duration for logic 1 and multiple transitions will happen during logic 1 level. Whereas edge triggering flip-flops, the state transition happens only at the edge. So we can eliminate the multiple transition problem. So one of the biggest problem with the latch is that we have to overcome the issue of the time interval of the logic 1, which is too long, because you do not make use of the clock pulse. I have specified that here. If you see here, both latches and flip-flops are the circuit elements whose outputs depend not only on the current inputs but also on the previous inputs and outputs. Whereas the latch and the flip-flop, the main difference lies in the fact that latch does not make use of the clock signal, whereas flip-flop does make use of the clock signal. So if you have observed or if you have gone through the tutorial of the latches, you will be able to see that mainly there we focus on level triggering, okay, because we are talking about the control signal that appears across, say, the SR latch means the control signal that appears across the S and R, okay. So in the case of the flip-flop, we are going to see how we can overcome this problem of the latch. We will also look into the level triggering using the flip-flops, and we will also see edge triggering using the flip-flops. Now coming to the level triggering or the pulse triggering. We said that in the flip-flop we can make use of the clock. Now the clock can be triggered using high level triggering, or you can make use of low level triggering. High level triggering means the trigger occurs on the high clock pulse, that is at this particular point. And low level triggering means the trigger occurs at the low clock level, that is shown here. Okay. Mainly in the concepts that we are going to study, we will focus on high level triggering, that is this particular type. Now, transition of the control signal, as to how the clock signal transition occurs. This is very important, especially when you are going for edge triggering. So low to high, that is, you have the transition of the control signal from its low level to a high level, that is from 0 to 1 in the positive logic will be called as the rising or the leading or the positive edge of the control signal. So you can see the positive pulse wherein this is the 0 to 1 transition, that is low to high, and this is referred to as the rising, leading or the positive edge. Whereas when the transition of the control signal from its high to low value, that is logic 1 to logic 0 occurs, it is called as the falling or the trailing or the negative edge triggering. So you have a positive edge in this particular case, you have a negative edge in this particular case. So in both the pulses, if you observe, you have both positive edge and negative edge. Triggering or the transition of the control signal is dependent on you as to how you observe, whether you want to go for positive triggering or if you want to go for negative triggering. We will be studying both positive triggering and negative triggering. Also, we will look into the initial flip-flops where we will apply the level triggering.